Hello students, today in this lecture we will discuss about direct indexing and simple or plain indexing. As in previous lecture we have discussed what is the indexing. In indexing, as we know, workpiece can be rotated in certain slots or in certain interval to generate the gear teeth or to generate certain number of teeth on the workpiece. So let us understand first direct indexing. So to understand this direct indexing, just let us have a look at this figure, and as you can memorize, this figure is nothing but similar to that of the plane dividing head. In direct indexing method, plane dividing head is used, and in this index plate that is directly mounted on the spindle. As you can see in this figure, over here indexing plate is shown, and this indexing plate has certain number of slots over it at certain interval, and this indexing plate has crank and crank pin arrangement, and with the rotation of crank in this indexing plate, this rotates the job. So please keep this in mind. This crank is directly connected to the workpiece. So this rotation of crank result into rotation of the workpiece. And to calculate the indexing ratio required for any machining operation, you just need to use simple equation that you can see over here. So the resulting required ratio can be obtained by using this simple equation, which has notation capital N divided by the small n. So what is capital N? This capital N is nothing but the number of slots on the periphery of the index plate. That means, as you can see from the figure, this indexing plate has 24 number of slots over its periphery. That means for any circle there are total 360-degree angle, and there is 24 slots available at equal distance on this 360-degree angle. That means if you want to measure angle between two slots, that is nothing but 360 divided by 24. So that will give you the angle between two consecutive holes. So over here small n, that is nothing but number of division required that are to be machined on the workpiece. So to understand this direct indexing, please keep it in mind. For this direct indexing method, plane dividing head will be used only, because we have studied plane dividing head and universal dividing head. But for the case of direct indexing, only and only plane dividing head will be used. And as we know, plane dividing head is useful up to the plate which have 12 to 24 number of holes on its periphery. That means maximum 24 number of holes or 24 number of equidistant teeth can be generated on the workpiece by using this direct indexing method. So let us take an example. Suppose the circumference of a job has to be divided into 6 equal divisions and the index plate has 24 slots, then the required ratio is. So as I have told you, for any of the numerical, first try to find given data and then try to find what are the result they are accepting. So now for this particular case, as you can see, there are 6 equal divisions are required on the workpiece, and the index plate has 24 number of slots. That means the required indexing ratio that can be obtained using above equation. So just try to solve it and now compare it over here. So as you can write, what is the capital N? Capital N is nothing but the number of slots on the periphery of index plate. That means over here capital N, that is equal to 24. Similarly, what are the number of divisions required on the workpiece? So over here 6 equal divisions are required. So that means small n, that is equal to 6. So just putting this value in above equation, you will get required ratio that is equal to 24 divided by 6, and that will give you nothing but 4 divided by 1. So what is the interpretation of this result? So as you can see, to generate one hole or to generate one division on the workpiece, the crank needs to be rotated through index plate by 4 holes. That means index plate will require to move through 4 slots after each cut is completed. So on 24 hole plate, first set the crank to 0 initial position. After setting that crank at initial position, rotate the crank through 4 slots, which will rotate workpiece. And after rotating that 4 slots, perform the cutting operation. After cutting that particular teeth, further rotate that particular crank from available position to next 4 slots, and repeat this procedure up to the 6 number of divisions that are obtained on the workpiece. And that is how, by using just a simple direct indexing method, one can obtain in the range of 12 to 24 equal number of division on the workpiece. So this is the oldest method which is used to generate this number of slots on the workpiece. Now we will see another method, that is simple or plain indexing. So where this method will be helpful? So as we know, in normal direct indexing method, one can generate only up to 24 number of equal divisions on the workpiece. So now if one want to generate more than that number of, or more than 24 number of holes or 24 number of slots on the workpiece, or any other number of workpiece that are to be generated by using universal dividing head. So in this simple or plain indexing method, universal dividing head will be used, and for this the figure will be similar to that of universal dividing head. So as you can see in this figure, there is a brown or sharp indexing plate will be available, and these brown or sharp indexing plates are available in 3 different number of sets that we have studied in our previous lecture. Similarly, this indexing plate has crank and crank pin which connects this indexing plate and final our workpiece. So now we have seen in universal dividing head, this universal dividing head consists of the worm and worm wheel arrangement, and it has fixed gear ratio, that is 40:1. And further I am repeating it. What is the meaning of 40:1 gearing ratio? That means rotation of crank finally result into rotation of the worm gear, and this worm gear rotates the worm wheel, and the worm wheel rotation gives the final rotation to the workpiece. So over here, when we rotate crank 40 times, or the rotation of 40 complete revolution of crank result into 1 complete revolution of the workpiece. So that is the major interpretation of this gearing box having gear ratio 40. So now let us have a look. It has main parts. First one is the brown and sharp indexing plate, and another one, that is the worm and worm gear, which is having ratio 40. And for this simple or plain indexing, the required ratio that can be obtained using the equation 40 divided by n. And to understand this, over here this small n will give you nothing but the number of division required to be machined. That means if one want to generate 23 number of holes on the workpiece, so this n, that is the nothing but required number of slots or number of divisions on the workpiece. So let us take an example for this also. So example is, the workpiece is to be divided into 23 equal division, then the corresponding crank movement will be. So over here you can think that in our previous topic we have discussed that this direct indexing method will be helpful to generate holes up to 24 number, and over here these 23 equal divisions are nothing but the less than 24 number of holes. So this may be generated using direct indexing method also. But if you divide 360 divided by 23, you will come to know that it will give you some value that have points. That means it has certain value, maybe 12.66, maybe 12.77. so how you can accommodate that 0.77 value? So that value in points that cannot be accommodated using simple hands. So due to that particular disadvantages, this simple or plain indexing method is used. So simple, as given in example, the workpiece is to be divided into 23 equal divisions. So over here our small n, that is nothing but 23, and the corresponding crank movement that is obtained by using equation 40 divided by n. So 40 divided by 23. Now this fraction form further convert it into a partial fraction form, and that will give you 1:17 divided by 23. So what is the interpretation of this particular value? So as you can see, it has number 1:17 divided by 23. So to interpret this, what I am saying to you, keep it in mind very clearly. This denominator will show, this denominator value 23 will give the detail of number of holes available on the indexing plate. This numerator value, that is the 17, that will give you the detail about how many number of holes that needs to be rotated on the indexing plate using crank. And the first value, that is 1, that gives the interpretation that to perform 17:23 operation, first one need to complete one complete revolution. So combining all this detail, I will be giving you perfect interpretation for this number. So this gives the result that to generate 23 equal division on the workpiece, for one equal division one needs to rotate, one complete revolution needs to be given to crank, and after giving one complete revolution, 17 holes to be moved on 23 holes indexing plate. So for this particular example, if we say for each division on the workpiece, the crank will make one complete revolution and will move further through 17 holes on 23 holes circle. So this is the one movement that is required. So if I say from this figure, let's have a look. If over here, this is our initial position. So first complete one complete revolution. So this one complete revolution is required, which will rotate the job by certain angle. After providing one complete revolution, suppose these are the 23 number of holes available on the indexing plate. Now rotate this crank by 17 holes. Suppose up to here 17 holes are available. So now crank will be rotated from initial position to up to 17 number of holes and stop over here, and due to which whatever the angular movement to that or whatever the rotation that are given to the job will provide you one division and perform the machining operation. Now after performing that machining operation, wherever the crank is available, suppose crank is available over here. Now further give one complete rotation up to here, which is nothing but the one complete rotation, and from this initial position further rotate 17 number of holes on this indexing plate and stop over there, which will provide you another movement for the division. Now perform machining operation and repeat this procedure up to until 23 equal number of divisions obtained on the workpiece, and this will give you equal number of rotation or equal number of division on the workpiece for gear cutting. So this is nothing but the simple or plain indexing method. So in this lecture we have discussed about simple two methods, that is first one is direct indexing method, in which directly crank is connected to the spindle and which is directly connected to the workpiece, whereas in simple or plain indexing crank is connected to the worm and worm gear arrangement, and after that worm wheel is connected to the workpiece. So due to the available gearing ratio, that is 40:1, the motion is transmitted from crank to the workpiece and final rotation is obtained. And how the division can be obtained, that we have also seen in the case of this simple or plain indexing. So you can try more number of example and it is easy for you to understand this simple or plain indexing method. So in our next lecture onward, we will discuss about another indexing method, that are compound indexing and differential indexing. So looking forward to see you all in our next lecture. Up to then, thank you.